The phrase exponential growth is familiar to most people, and yet human intuition has a hard time
Can
really
y'all hear it?
recognizing what it means sometimes.
Yes,
We
ma'am.
can anchor on a
Okay.
sequence of small seeming numbers and then become surprised when suddenly those numbers look big, even if the overall trend follows an exponential perfectly consistently. This right here is the data for the recorded cases of COVID-19, aka the coronavirus, at least at the time that I'm writing this. Never one to waste an opportunity for a math lesson, I thought this might be a good time for all of us to go back to the basics on what exponential growth really is, where it comes from, what it implies, and maybe most pressingly, how to know when it's coming to an end. Exponential growth means that as you go from one day to the next, it involves multiplying by some constant. In our data, the number of cases in each day tends to be a multiple of about 1.15 to 1.25 of the number of cases the previous day. Now, viruses are a textbook example of this kind of growth, because what causes new cases are the existing cases. So if the number of cases on a given day is n, and we say that each individual with the virus is exposed to, on average, e people on a given day, and each one of those exposures has a probability p of becoming a new infection, then the number of new cases on a given day is e times p times n. And the fact that n itself is a factor in its own change is what really makes things go fast, because if n gets big, it means the rate of growth itself is getting big. One way to think about this is that as you add the new cases to get the next day's count, you can factor out the n. So it's just the same as multiplying by some constant that's bigger than 1. This is sometimes easier to see if we put the y-axis of our graph on a logarithmic scale, which means that each step of a fixed distance corresponds to multiplying by a certain factor. In this case, each step is another power of 10.
That was good enough. I just want to show you one application of exponential functions and logarithmic functions, which is what we're going to discuss today. We're going to talk about logarithmic functions. All right, stop sharing. So 3.2 is logarithmic functions in their graphs. We're going to recognize and evaluate logarithmic functions with base A. We're going to graph logarithmic functions. We're going to recognize, evaluate, and graph natural logarithmic functions. And since we talked a little bit about how exponential functions and log functions are applied in the real world, I may skip real life problems. Definition of logarithmic function with base A. Let's look at this. All right. So we have y equals, and this is how you say this, y equals log base A of x. That's how I say it. Y equals log base A of x. That's called the logarithmic function. All right. So let me write that down. Hold on. Get my pen. I kind of want y'all to kind of block it off if possible, so you can highlight it. So put a rectangle around it. Let's do it like this. This is called the logarithmic form. And this one over here, it says if and only if x equals a to the y. This is called exponential form. They mean the same thing. All right, we'll get to that later. But how you say it again? How do you say the logarithmic form? Can anybody remember what I just said about 2 minutes ago? How would you say this that's boxed off in fuchsia or purple here? How do you say it?
Y base A
Mm-hmm.
of X.
All right, y equals log base A. I want to hear that base. So I heard somebody, a couple of y'all said base. Base A of x. All right, good. So remember that. It says a logarithmic function is the inverse of the exponential function. So on Tuesday, we talked about the exponential function. Now we're just doing the inverse of the exponential function. All right. So recall the exponential function that we talked about on Tuesday, 2 to the x power. Here are some values for that. It looked like this on the right. 2 to the x looks like this. Now, if I said, let's graph the inverse of 2 to the x using the table of values above. Using these values, how would we find the inverse of 2 to the x? Do you recall what we used to do?
You would switch the x and y values.
Very nice. All right. Let's switch the x's and y's, okay? So above, for example, we had -3, 0.125. Now we will have what as a point?
-3. 0.125 to -3.
Correct. Somebody else, give me the next point. Somebody other than Akira.
0.25, then -2.
Thank you. Someone else. What would be the next point?
0.5 and negative.
Yep, 0.5, -1. Next.
1 0.
1 0. Next.
2 1.
Good. Next.
4 2.
All right, good. So it seemed like y'all caught on to it. Everybody caught on. All we're doing is switching the x and y's of the exponential function 2 to the x power. We're doing the inverse of that function, which is called a logarithmic function. So let's plot the points. How do we plot 0.125 -3 if we're at the origin? How do you plot that? (0.125 -3).
You're gonna go to the right.
0.125. That's the only way I can say it. 0.125, and then
you're gonna go down.
Okay. How many units?
3.
All right. Good. Okay, so we'll do that. Then 0.25, I don't know, somewhere around here. And then 0.5 -1, 2 1. Nope, skipping. 2 1 and 4. 2 3 4 4 2. So it's doing a little something like this. Okay. All right. So does it look like the inverse of the green? Remember, we used to put a little dot right here. All right. To be honest with you, you already see this graphic at the top of your paper, right? I just wanted to go through it so you can see where did it come from. You see at the top, f of x equals 2 to the x, and you have a logarithmic function, which is y equals log base 2 of x. So they are inverses of each other. Obvious by the fact that if you they're like mirror images of each other across this line y equals x, symmetric about the line y equals x. All right, let's move on. The following equations are equivalent. I'm repeating myself. It's the same thing. The following equations are equivalent. Log base a of x equals y means a to the y equals x. Again, let's see if you remember. What form is this called? What form is that? log base A of x equals y?
Logarithmic.
Logarithmic form. I'm repeating myself because sometimes that helps us remember. All right. Then over to the right, it means the same thing as a to the y equals x, but what form is that?
Exponential.
Exponential form. Okay. Notice that the bases are the same in both. Okay, so the base, we have the base a over here. In the exponential form, the a is also the base. All right, so here's how I kind of get from logarithmic form to exponential form. And I'm pretty sure a lot of other tricks, and if y'all recall any tricks, please let us know so we can remember. But what we're going to do is the base a, all right, the base a to the y, just draw an arrow, to the y equals x. So I draw a little graphic like that. And I'm going to write all this out for y'all. All right. So a raised to the y equals x. That's how we get from logarithmic form to exponential form. The base a raised to the y equals 8. So let's look at this example down here. So log base 2 of a equals 3 means the base 2 to the third power equals 8. Log base 2 of 8 equals 3 means 2 to the third power equals 8. All right. So the base of the logarithm is the same as the base of the exponent again. Just repeating myself. All right, let's go to some examples. Let's evaluate each logarithm at the given value of x. A is f of x equals log base 2 of x, where x is equal to 32. How do you evaluate a function from what you've learned in pre-calculus? Somebody other than the Curia. How do you evaluate a function?
You substitute.
Okay, you substitute what for what? Sorry, y'all.
You substitute like the x value.
Okay, in this case, we're substituting the x with what? Somebody else other than
30.
Mary. Okay,
32.
32. 32. 32. So that's our first step. Just make a substitution. All right, so this means, let's write this log base 2 of 32 as an exponential form. Where do we start? We always start with the what when we're trying to write it in exponential form?
The base.
Let's start with the base, yes. So the base here is what? Somebody other than the Curia.
Is it 2?
Yes. So the little subscript number is our base. 2 to the something, let's put y, right? That's where f of something is. It's our y. 2 to the y equals what?
32.
We just, yep, 32. We wrote it in exponential form to try to figure it out. So we got to figure out 2 to the what power equals 32? What do y'all think it is? What is y? That's the question.
Fifth power?
The which power? Say it again.
The fifth? To the fifth?
To the fifth. Okay. Yep. And all you have to do is just put some numbers in the calculator. 2 to the 4th, 2 to the 5th, 2 to the 6th. See which one is right. Very good. So as a result, we know the answer is 5. And I'm going to write it all out. Not necessary that I write it all out, but I don't have enough space right there, really. So f of 32 equals 5, but I'm going to write it all out. Log base 32 of 2 equals 5. Let's go on to B if you don't have questions. All right. Same thing here. Someone other than Merrick. What are we substituting for X? For B?
1.
1 this time. Okay. F of, I'm gonna come back and color code. Y'all know I like my color code. All right, 1. All right, what does it mean? Let's write it in exponential form. What does it mean? We start with the what again? What do we start with?
The base.
The base.
The base, which is
3.
3 to the what?
The X or
Or we're gonna say y, because then we replace the x with something. Y'all see that?
Mhm.
So we do 3 to the f of 1, but I don't want to write f of 1. I want to write something simple. Y. F of x is the same thing as y. Equals
1.
1. All right. What do you think y equals then?
0.
0 is correct. Anything to the 0 power equals 1. So again, we write it all out. F of 1 equals 0, but I'm going to write it out as f of 1 equals log base 3 of 1 equals 0. Any questions so far? Because we're done with the first page. Any questions? More examples. So for C, we're still evaluating X at what number this time?
2.
Yep. 2. What does it mean? This means, what does it mean? We start with the, to change the exponential form, the base. The base is what?
4.
4 to
Four.
the 4 to the y equals 2. This one a little bit more challenging. We got to figure out what is y. What y will work. All right, 4. So we got a situation where we have a 4 and then it reduces down to a 2. What situation do you normally see that happening in? We have something 4, but it reduces down to a 2. But this has to be an exponent. Interesting.
So would it turn to a fraction?
Ooh, okay. Would the exponent be a fraction?
Yes, ma'am. It'll be 1/2.
It'll be 1/2. And the reason why is because the square root of 4 equals 4 to the what? Gotta go back to algebra now. All right, what's considered to be the index in this square root symbol?
Is 2?
Like 2?
2.
Okay. All right, 2 over here, but what's considered to be the exponent right here? 4 to the what power?
1 first.
1. So this is the same thing as 4 to the 1/2. All right. So let's do a little algebra review. What if I ask you, how would you write the cube root of 4? 4 to the what?
1/3.
4 to the 1/3. If I ask you, how would you write the 7th root of 4 as an exponent? It would be what?
4 and 1
1 7.
4 and 1/7. Uh-oh, I might throw you off with this one. What if I put the 9th root of 4 to the 5th power? How would you write that?
Mm,
All right. So the numerator is this number. I was trying to see if you got it. The numerator is that number. The denominator is the number inside the little v part.
4, 5, 2.
Okay. Yeah. All right. That's a little algebra review for a second. We're moving on. All right. So y equals 1/2 is the answer. So let me just write it all out. F of 2 equals 1/2. I'm going to write it all out like this. Moving on. D. We have f of x equals log. What's the base for this one? For D.
10.
What's the base?
Yeah.
10. All right. We're going to replace our x with 1/100 this time. That's going to be challenging. 1/100. All right. What does it mean? It means what? We start with the
Base.
base 10 to the
Mm,
what am I use 10 to the, just write it first. We're just writing it. We're not trying to figure it out.
what?
Y? Right. 10 to the y equals, just writing it. Don't try to
1
figure it
over
out.
100.
100.
100. Okay. That's how you write it in exponential form. All right. Then we can kind of figure out what's going on here. I'm going to let you think about it for 30 seconds. See if you can guess, make a good guess at it. But, you know. Anybody has a good guess yet? It could be wrong. We're learning.
-2.
Oh, how did you get that?
I just plugged in numbers.
Okay, that works too. All right, very good. All right, so let's break down 100. When you agree that 1/100 is the same thing as 1/10 squared, would y'all agree
Yes,
that?
ma'am.
Yeah. And would you agree that 1/10 squared is the same thing as 10 to the -2?
Yes, ma'am.
Yep. So therefore, 10 to the y equals 10 to the -2. Now we learned from Tuesday about the one-to-one property. What does the one-to-one property say? What does the one-to-one property tell us? That when it looks like this, meaning what? We can do what? What's the next step?
You solve because both of the bases are the same.
Very good. Both of the bases are the same. So what do we do with the bases then?
You multiply.
What do we do with the bases
Oh.
for the one-to-one property?
You like get rid of them.
You get rid of them. You throw them away. Because if 10 to the y equals 10 to the -2, it must mean that the exponents equal each other. So y equals -2. We just get rid of the bases altogether. All right, that's the rule with the one-to-one property. So y equals -2. All right, so f of 100. So you see now that you're may have to manipulate numbers to make it work for you. All right, so the answer is -2. All right, let's talk about something called the common logarithmic function. Why is it called a common one? I don't know, but it is the most common one that you will see on your calculator. So I'm hoping you have a calculator nearby somewhere. I want you to locate this logarithmic function that has a base of 10. So it could be written log base 10 of x,
Use my phone
or
calculator.
it's the same thing as log x.
How are you feeling?
All right, so log base 10 of x equals log x. All right, so they mean the same thing. I want you to locate it on your calculator. All right, locate it on your calculator. Do you see log x? It means log base 10 of x. It's the most common logarithmic function.
Dr.
Can
Tom,
you put a, yes.
okay. I see log by itself.
You see log? That's good. That's good. That's good enough.
Okay.
That's good enough. Yep. All right. It means base 10. So you're not going to see the base 10 on the calculator. All right. And you're not going to see the x either, as always is showing us. You're not going to see the x, just see log. All right. We're going to practice using our calculators. Okay. We're going to use a calculator to evaluate the function f of x equals log x at each value of x. All right. So the first one, x equals 10. We're evaluating log x at x equals 10. So let me write it all out. I know you don't have to write it all out, but I'm going to write it all out for you. So what are we replacing x with again for this one?
10.
10. All right. You just simply put log 10, enter in your calculator. What did you get?
1.
1.
Very nice. Any questions? Did everybody get to the 1? All right. So logarithms look hard. They look very hard. But isn't it easy so far? It's pretty easy, y'all. All right. Don't make it complicated. Okay. We have f of something equals log of something. All right. We're going to figure out what f of 1/3 is, which is log of 1/3. You might have to put parentheses around the fraction. I don't know in your calculator. But what does log of 1/3 equal to, according to your calculator? Let's do 3 decimal places maybe. What do y'all get?
I got
Don't be
negative 0.477.
all right. Sounds good to me. Did everybody get to negative 0.477?
Yes.
Very nice. Then we're going to try out this negative number here. What happens when you try out this negative number?
Error.
Yes, error. So apparently we can't do logs of negative numbers. You can try more if you want to. Let's write, as a proof, let's write it in exponential form. How can we write log of -2 in exponential form? Log of -2. Ooh, this is a good question. What do we start with, everyone?
The
When
base.
yes. We start with the base. What is the base of log? Plain log.
10.
10. Here you go. I highlighted it for you. Log base 10 of x is the same thing as log of x. So if you do not see a base, it's considered to be 10. Write that down. If you do not see a base, it's considered to be 10.
Dr. Thomas, it's 10 because we can't use -2.
No, I'm just asking what the base is. That's
Okay.
all.
Okay.
It's not the answer. Is error the answer? All right, proof. 10 to the, that's the base. How do we write it in exponential form is what I'm asking. 10 to the, how do we write it in exponential form?
What? 10 to the y?
Yep, equals.
-2.
Yes. So it we don't know a y that would make this work. Y'all see that? We can, 10 to the something equals -2. There is no y that would make that happen. So that's why there's an error. All right. You always get errors when you're trying to do logs of negative numbers. All right. Let's look at properties of logarithms. Here are 4 properties that I want you to memorize. The first one, it says that if you have a situation where log has a base a and the number right by it is 1, it will always equal 0. All right, let's look at this. How do you change this to exponential form? All right. Somebody other than the carrier. Log base a of 1. Uh-huh.
AY1 equals
See, here they give you everything, right? All right. So a to the,
y.
all right, here's how I do it. Here's how I do it. I take the base, that's what we write first, and I swing an arrow over here to the
0.
0 equals
1.
1. It's over here. I just want to see if you could remember. All right, you always take a base to what it's equal to and turn around and come back to the normal number by the log. All right. The reason why it's going to be equal 0 because if anything to the 0 power equals 1. All right, let's look at the next one. Remember this rule. If these two things are the same right here where the A's are, in these positions, if these two things are the same, then the answer is the exponent of the big A. What's considered to be the exponent of this big A right here?
1.
1. It will always be 1. Number 3, that's basically what this is saying. If these two numbers are the same right here, this A and this A, then your answer will always be what the exponent is. Always. All right, so that's part A of number 3. The other one is this one on to the right. A to the log base A of x will always equals x. I don't know, ever since I was in college, I used to kind of like cancel all this out, and I knew my answer was going to be that. I don't know why. That's how I did. I kind of act like they were canceling each other out. Why? Because they are inverses of each other. You have exponents and you have a log at the same time. They're kind of like inverses of each other, so it cancels out. So I always use just draw a line through it. And then the answer is what's next to that base. All right, the last one is the one-to-one property. Oh, somebody, okay, y'all, that's not properly, y'all. This will be property. All right, I did a screenshot, and that ain't right. Property. All right, so it says that if you have the same log and the same base, then you just going to set this equals this and solve. So those are 4 properties I want you to memorize in this chapter. All right. Let's use these properties for the next 5 examples, 6 examples. All right. For part A, log base A of 8. Which property it looks or it resembles the most to you? Property 1, 2, 3, or 4?
1.
2.
2, right? Why you say 2?
Because the A and the A is 8, 8, 8.
Mm-hmm. The A's are acting like the 8s are acting like the A's. And according to property 2, let me write that down. Property number 2. According to that, what's the answer? According to number 2, the answer is
1.
1. Yes. That's
1.
all you have to do. If you know the property, you don't have to think about it. You just write the answer. All right, B. Which property closely resembles log base 7.5 of 1? Which property you think?
1.
Yep, I think so. Property number 1. All right. According to property number 1, log base A1, what does it equal?
1.
0.
Property 1,
0.
0. 0. All right, so we're looking at this. These are the explanations up to the right. All right, that's why it's true. All right, let's look at C. Log base pi of pi squared. Which property?
3.
3.
Yep. You still got the same AA here, but the answer is supposed to be that. So, according to property number 3, what is the answer?
2.
Very nice. It's the exponent. All right, let's look at D. Which property does it look like?
4.
None of them.
Property. Any more guesses?
3. 3.
3.
3.
Yep. This one over here, right? We're going to call it 3B. All right. We're going to call this one 3A up here. 3 part B. All right. So according to this, remember I was just saying, if what's in the spot for the A's are the same, you kind of cancel that out, right? What's the answer then?
3.
3. So again, I kind of like cancel those out, and what's left is this number right here. All right, let's look at E to the right. We have log base 5 of x plus 1 equals log base 5 of 6. Which property is it?
Is it 4?
Yes. Property number 4. This is the 1-to-1 property, which says that we have the same log on both sides with the same base. Then what can we do with the log 5s? What should we do with log 5 now that we see that they are the same on both sides?
You cross them out.
Yep, you get rid of them. You don't even think about it. We said what equal each other.
The exponents.
It's not really an exponent. It's not raised, right? It's not really exponent. So just tell me verbatim. Just read it. What are we setting equal each other?
It'll be
X plus
parentheses.
X plus 1 equals 6.
6.
That's all we're doing. All right. Solve for x by doing what?
Subtracting 1 from both sides.
X equals
5.
5. How do you check your answer? just in case you want to make sure your answer was right. How do you check it?
Put the 5 where the x is.
Very nice. Think about it. If most of your test, if most of it is multiple choice, some of these y'all can check if you really wanted to. All right, plus 1. And I didn't even have to write this out. Y'all see that the left side equals the right side, right? All right. So y'all see that log base 5 of 6 equals log base 5 of 6. So it checks out. The left-hand side equals the right-hand side. So that's how you know your answer is 5. All right, moving on. For F, what are we doing for F? Which property? Property
4.
4 again. We have the same log on both sides. What's the base? I'm just asking. We don't need it, but what's the base?
One.
Is it 10?
Let's go. 10. Let's go back. Let's go back. Gotta go back and review. Let me highlight it. Here we go. If you do not see a base, it's considered to be 10. All right. If you do not see a base, the base is 10. All right. So we're going to set what equal each other. Just read it for me. What are we setting equal each other? Since we're using
X
property
squared
4.
plus 6
Yep.
equals 7.
Correct. What would be our next step in solving this equation?
Subtract 27, get everything on the same side.
Very nice. How you know you got to put everything on some? So sometimes you put everything on one side, and the other times you don't. How did you know you had to put everything on one side?
Because then you'll be able to factor it out.
But how did you recognize?
Oh,
it?
because there's
Look
no
at
common no common base. No, what's the word? You know what I'm trying to say. No common factors, I guess. No common. You know.
The x squared.
the x squared. Okay, very good. So here's a little tip. If your degree is higher than 1, I'm gonna say 2 or more, but higher than 1. I'll leave it like that. And you need to move everything to one side. What's the next step after you move everything to one side?
Find the common factors.
Not common factors. What I want to find just the regular
Oh, yeah, it's just the factors.
factors.
Common factors.
All right, just the factors. So we're gonna factor. That's the second step. All right, what are the factors? That's a good question.
-3 and 9.
Tell me exactly what I should write, Christine.
X
Exactly.
-3.
Okay,
X plus 9.
Okay. Very nice. Okay. You said x minus 3, x plus 9.
Yes.
All right. Or vice versa, x plus 9 times x minus 3. All right. What's the next step?
You set them to 0.
Correct. What are we setting to 0?
The factors.
The factors. X minus 3 is a factor, so we're going to set that to 0. And we really want to show we smart. We put or in the middle. And then x plus 9 equals 0. All right. What are the solutions?
3 and -9.
Very nice. And again, check. That's a good habit. I'm going to move forward, but you could check both of those separately, all right, into the original logarithmic equation to see if the left side equals the right side. There's one more type of logarithmic function. It's called the natural log. That's how I say it, the natural log. All right, it's f of x equals log base e of x equals ln x. But it's called a natural log of x. That's how we say it, the natural log of x. I hear some people say ln(x) though. All right. What is the base for the natural log function? I just said it. What is the base? You see it. It's in front of you. What is the base?
E.
E. Yes. And does anyone remember what we said E was approximately? It was approximately something we talked about Tuesday. Do y'all recall what it was?
It was 2 point something.
Mm-hmm. That's good enough. 2 point something, something, 1 something, 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 something. Very good. All right. All right. So let me ask this question. See if you caught on to it. Other than log base E of x, other than log base E of x, how else can we write that? Write the natural logarithmic function. You probably gonna think this is so redundant. Why is she asking us these easy questions? I don't know. I just want to see. All right. What's another way to write log base E of x? Just guess if you don't know.
X to the X. F of X
Oh,
equals E to the X.
I was just looking for ln(x). That's all. But yeah, that's good too. I was just looking for this. All right. It's the same thing. All right. But you said e to the, I like that. Okay. I might have to write that, add that question. All right. So exponential form. Yeah, let's add that. Exponential form would be what? What did you say? Somebody said
E X E to the
E.
Mhm.
E to the,
X.
what did we say to put? Because we're doing e to the this. What is this the same thing as?
Y.
Y. Then we go back, bam, over here, equals x. So that would be the exponential form. All right. Let's practice evaluating again. This should be simple, but let's practice. Evaluate the natural log function using the following values. I already gave you the answer. I just want to make sure you practice using your calculator. So, for the natural log function, do y'all see ln as well on your calculator? Then you should also see a button that has ln on it. That's your natural log. All right.
Yes,
So
ma'am.
try, all right, good. Try 2. ln2, enter. See if you get 0.693, something like that. All
Yes,
right,
ma'am.
put a 1 in the chat if you got to 0.69 something, 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 something. All right, good. Let's go on to B then. I'm feeling good about A. B, plug in 0.3. What is the natural log of 0.3? Do you get negative 1.20 something something?
Yes, ma'am.
Very nice. Anybody having any issues so far? We'll plug it in your calculator. All right, and C looks interesting. Let's try plugging in 1 plus the square root of 2. So ln of 1 plus the square root of 2. Do you get 0.88 something?
Yes, ma'am.
Yes. Okay, good. And D, try end up with a negative number again. So just like with regular logs, natural logs also will give you a what if you plug in a negative x value?
An error.
An error. All right. If you look at this graph up here, notice the natural logs are over here. Notice it's not even over here with the negative x values are. All right, this graph is house right is home is right over here to the right, not on the left side where the negative values are. All right, properties of natural logarithms are similar to the properties you already learned. They look almost identical. The first one is ln of 1 equals 0. All right, because e to the 0 equals 1. Where did they get e from? I don't see an e. ln 1 equals 0. Where did the e come from?
It's the base.
It's the base. Again, log base e of x is the same thing as ln of x. So the base. So if you imagine that saying log base e, then it's e to the 0 equals 1. Very good. Property number 2, ln of e equals 1. Again, base is e to the 1 equals e. So property number 1, if you have 1 in this spot, the answer will always be 0. If you have a natural log of e, again, ln of e is the same thing as log base e of e. And according to that property we learned earlier, here, when the a and the a are the same, the answer is 1. All right. In this case, what we have is the e and the e are the same. All right. So the answer is 1. Property number 3. Again, natural log is the same thing as log base e. So we have ln of e to the x is the same thing as log base e of e to the x. It's sort of like this cancels out, and your answer is just that exponent right there. One-to-one property again. If you have natural log on both sides, you can get rid of it and just set x equals y. All right. So we just have one more problem, and then I might throw a few at you, and that's it for today's lesson. Use the one-to-one property to solve the equation for x. So I'm going to give you 2 minutes to work on this one. ln of x squared minus 2 equals ln of 23. First, which property are you going to use? Which property? 1 through 4. Which one? All right, don't get sleepy on me now. Which property?
Is it 3?
For this one?
4.
Yeah, okay. Use property number 4. We have the same thing on both sides. See that? We have the same thing. We still have the same natural log on both sides. So we can get rid of it. All right. So work on that. I may take some from the book. And that's it. All right, hold on. Somebody making a comment. No. Try it again. Well, hold up. That's 1. That's 1. I'm going to say that, Monisha. That's 1.
Are we supposed to send the answer to you, or are we supposed to say?
No, she just said that.
Is it 5 and negative 5?
Correct. All right. Let me go ahead and see if everybody else can get to both of those answers. And then let me pull up the ebook right now. All right. The degree of that was what? Again, so I want y'all to use what y'all learned in class. What's the degree of your equation?
2.
2. All right, so that tells us a lot. Normally, that tells us a lot. It tells us that we might need to move everything to one side. That's one thing it might tell us. And also, it may tell us that we have two solutions. Okay, so don't forget things like that. All right, I'm going to stop this. All right, do I need to work it out, everybody? Do y'all want to see me work it out? Anyone? Say yes.
Please.
All right, very good. So we're just going to say, again, it's almost like since the LNs are on both sides, we're going to use property 4, see how the LNs are on both sides here. We get rid of the LNs, and we just set x squared minus 2 equals 23. Then I think it would be best to subtract 23 from both sides. Then you have x squared minus 25 equals 0. What should you do now? What's the second step when you move everything? Yep. This is a difference of squares, so x plus 5 times x minus 5. You set each factor to 0. And that's where you get negative 5 and positive 5. Of course, you didn't have to go that route. As long as you remember there are two solutions, you would have been good, even if you added 2 to both sides. All right. Any questions about that one? All right, I'm going to share my textbook with y'all now so we can just practice a few for about 10 minutes and we're done. Let's see. All right, I'm just going to be choosing random ones. Okay, let's look at this one. Writing an exponential equation. Write the logarithmic equation in exponential form. For example, the exponential form of log base 5 of 25 equals 2 is 5 squared equals 25. Let's do number 7. Log base 4 of 16 equals 2. How would you write that in exponential form?
4 squared equals 16.
All right. Very nice, Christina. 4 squared equals 16. Bam. Okay. Let's skip to number 9. Let's skip to number 9. Somebody other than Christina. How would you change log base 9 of 1 over 81 equals negative 2 to exponential form? Somebody other than Christina this time. Number 9.
Would it be 9 to negative 2?
9 to the negative 2. Come on with it. What else?
Equals 1 over 81.
Oh, let's see. Let's see. 9 to the negative 2 equals 1 over 81 is correct. Very good. All right, we're going to move and skip. Skip, 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 skip. All right. This one says write the exponential equation in logarithmic form. So they want us to think backwards now. For example, the logarithmic form of 2 to the third equals 8 is the same thing as log base 2 of 8 equals 3. Let's try number 11. What would you say? Write it down. Make sure it works out. Both directions. How would you put that in logarithmic form?
It'd be
log 5.
Log 5.
Okay.
Log
Log.
5 equals
Say
3.
it right though. Log. What I want you to say in front of log what?
Base 5.
Okay. Okay. What else?
125 equals 3.
It'll be parentheses.
Log base 5 of 125. Put that of in there next time. Equals 3. Very good. All right. One more like that. 13. 4 to the negative 3 equals 1 over 64. How would you say that as a logarithmic function? 4 to the negative 3 equals 1 over 64. Anybody want to try it?
Would it
Log.
be
Oh,
log
sorry.
base 4 of 1 over 64 is equal to negative 3?
Ooh, nice. Very good. All right. Everybody see it? And if y'all put parentheses around the 1 over 64, I'm fine with that. I'm fine with it, okay? All right. Now, let's see. Do we need to skip? All right, let's try some of these without a calculator. Very interesting. F of x equals log base 2 of x. We're going to evaluate the logarithm given at the given value of x without using a calculator. Okay. So we're going to replace the x's with a 64. All right, I want y'all to work on it and see if you can get to the answer. If not, I'll work it out. Let's see. All right, are we getting anywhere? Let me snip that. Go to my ink workspace for a second so I can write on it. Okay. All right, so can I write on this? Let's see. F of 64 equals log base 2 of 64. Let's change it to exponential form. Tell me, what is it in exponential form?
You start at the base with this 2.
Yep, 2 to the,
Y.
yep, equals 64. 64. So what is y? That's the question.
6.
6. Very good. Let's skip to number 17. So that was 15. 17. F of 10 equals log of 10. It said without a calculator. Without a calculator. What do you think the answer is? All right. Well,
1.
let's try exponential form. Very good. What's the base of this one? Say it again.
Is it 1?
The base.
No,
What's the
base? The base.
10.
It's 10.
10. Very good. Let me say it. This is the third time. If you don't see the base, what is the base considered to be? 10. All right. 10 to the y equals 10. So that's why y equals 1. All right. Very good. Let's see what else. See, can I look at my screen and just write a problem out. Oh, this is a good one. Log base b of x. Let me just write it. What if it was f of x equals log base b of x, but x equals square root of b? All right, this will be the one for the road right here. Last one. First thing you do, plug it in. So, all right, it'll be log b of the square root of b. All right, we're not using a calculator. Can someone, from what you've learned today, tell me how can I rewrite the square root of b as an exponent? How can I rewrite the square root of b as an exponent? Make me proud now. Make me proud.
Would it be b and then 1/2?
B to the 1/2. Very good. Now, there's a property that we can look at to tell me something here. What property is it? 1, 2, 3, or 4?
3.
Go back. 3. Very nice. When these are the same, then what's your answer?
The exponent.
The exponent. 1/2 is the answer. All right, that's the last one for today, y'all. If you have questions, you still have questions, just stay behind. I will answer them.